Hello everyone, welcome to Study Desk. Today we are going to continue our chapter 1, Real Numbers, class 10 from NCERT. In this video we are going to discuss Euclid's division algorithm. So you might be wondering what is algorithm, right? An algorithm is a series of well-defined steps which gives us a procedure for solving a particular type of problem. Now, what is Euclid's division algorithm? It is a technique with the help of which we can calculate highest common factor HCF of two given positive integers. So, let's take the two numbers 6 and 18. Now, what are the factors of 6? They are 1, 2, 3 and 6. What are the factors of 18 now? 1, 2, 3, 6, 9 and 18. Correct? Now, what are the common factors of both of them? 1, 2, 3 and 6. So, these are the common factors of 6 and 18. But among them, what is the highest common factor? 6. Right? So, 6 is the highest common factor of 6 and 18. We can write down HCF of 6 and 18 is equals to 6. Now, this process is very time consuming. So, this Euclid's division algorithm will give us a technique with the help of which we can easily calculate highest common factor of two given positive integers. Now, let's find the HCF of 455 and 42. Here 455 is greater than 42, right? So therefore we will take 455 as our dividend and we will try to divide it with 42. On division we will get 10 as our quotient. So we will write down 42 into 10, that would be 420 here. On subtracting we will get a remainder of 35 here. So in terms of Euclid's division lemma, how could we write down this? Remember, for 455 is our dividend, 42 is the divisor, 35 is the remainder and 10 is the quotient. So, we will write down 455 is equals to 42 into 10 plus 35. Dividend is equals to divisor into quotient plus remainder. Now, we did not get remainder as 0. So, what are we going to do now? We'll consider 42, which is the divisor, and remainder 35 and apply the division lemma again. So, while applying the division lemma again, here 35 will be our divisor and 42 will be our dividend. So, 35 divisor and 42 dividend. 35 into 1, we are going to get 35. On subtracting, we will get a remainder of 7. So, still we have not got the remainder as 0. We will write down 42 dividend is equals to divisor 35 into quotient 1 plus remainder 7. Now, we will consider divisor 35 and remainder 7 and apply the division lemma again. So, while applying that, 7 will be our new divisor and 35 will be our new dividend. 7 5s are 35. Now, at this step, we got the remainder as 0. So, according to Euclid's division lemma, we will write down the statement as 35 is equals to 7 into 5 plus 0. At this process, we will stop the division algorithm. Notice that the remainder has become 0 and we cannot proceed any further. So, at the last step, when you will get the remainder as 0, you will stop your procedure over there. You will not go further. We will claim that the HCF of 455 and 42 is the divisor at the last stage when we got the remainder as 0, that is 7. So, what was the last step? We got 35 is equals to 7 into 5 plus 0. At this stage, we got the remainder as 0, right? So, at this stage, the divisor is 7. That is the reason we are taking HCF as 7. So, HCF of 455 and 42 is equals to 7. So, let's discuss all the steps of Euclid's division algorithm. To obtain the HCF of two positive integers, say C and D, with C greater than D, we will follow the steps given. First step will be apply Euclid's division lemma to C and D. So we find whole numbers Q and R such that C is equals to DQ plus R. So C is our dividend here, D is the divisor, Q is the quotient and R is the remainder. The condition that is followed here is R is greater than equals to 0 and less than D, which means remainder is greater than or equals to 0 and less than divisor. So step 2 would be if remainder is equals to 0, if R is equals to 0, D is the HCF of C and D. If remainder is not equals to 0, apply the division lemma to D and R again. Let's understand this step. So let's say you have two numbers 18 and 6. 18 is greater than 6. Let's do the division. We will get 6 3s are 18. Now at this step itself we got the remainder as 0. So we will write down it as 18 is equals to 6 into 3 plus 0. The divisor at this stage 6 will be the HCF of 6 and 18. So we will write down HCF of 6 and 18 is equals to 6. Now what happens if the remainder is not equals to 0? Let's take another example. 42 and 35. Now here if you will observe, you are going to get 35 into 1, 35 here, and the remainder you are going to get as 7. So remainder is not equals to 0, right? We'll apply the division lemma again, considering 7 as the new divisor and 35 as the new dividend. So 7 into 5, you are going to get 35 here. And hence, now your remainder is equals to 0. So here we will stop. Now observe here the steps. 42 is equals to 35 into 1 plus 7. In the first step, we did not get the remainder as 0. That's why we are repeating the step again. What are we doing now? We are taking 35, which is the divisor of the previous step, as the dividend, and 7, which is the remainder of the previous step, as divisor. We are multiplying 7 with 5. We will get remainder as 0 in this case. So here we will stop our procedure, and at this stage we will consider the divisor, which is 7, as the HCF of 42 and 35. So HCF of 42 and 35 will be equals to the divisor at the last stage, which is 7. So the third step was we will continue the process till we get remainder as 0. The divisor at this stage will be the required HCF. Thank you so much for watching.